Hello guys, you're welcome to our series of handling the mathematics UNEB items, and here we go. We are now analyzing item 4 after looking at item 3, which was enticing. Some of you commented, and I like that. So still under this item 4, some of these we are looking at basically item 4, which is made or constructed using data and probability, which is actually the theme. And under that theme, we have the constructs, which are the topics. So we have graphs, set theory, data collection and display, matrices, probability. So item 3 was on set theory and still data collection and display, and then there was some probability. When you look at item 4, which we are going to analyze in the, now, item 4 tells us that a farmers' cooperative society gave out fertilizers to a sample of maize farmers in the first season. The number of bags of maize harvested in the first season are given as below. The society wants, so the data is given there. The society wants, 1, the data to be presented in the frequency distribution table with classes of interval 10 for easy interpretation. Roman 2, to determine the number of bags of maize above which half of the farmers harvested so as to establish the real effect of fertilizers. 3, to determine the number of farmers whose harvest is 44.5 bags of maize and below for retraining before the second season, but they lack the information. Under the tasks, help the society to, part A, represent the data in the frequency distribution table. B, determine the number of bags of maize above which half of the farmers harvested. C, determine the number of farmers for retraining. When you look at this item requires us to display the collected data, because you can analyze and display data. Data can be displayed in a table form, tabular form, diagrammatic form, or graphical form, and any other ways, pie charts and all that. Data can be displayed in so many ways. But the one way we have here depends on what task that has been given to us. The task is that we need to find the number of farmers above which half, in fact, the number of bags above which half of the farmers. When you say half of the farmers, this was like 50% of the farmers, and we also say below half. It always takes us to the median. It takes us to the median. Then once we talk of majority, the number of bags exhibited by majority of the farmers, many of the farmers, this takes us to mode. Then when we say average, or the common value that the each farmer exhibits, it all takes us to mean. So these are the three different ways you can look at the task and know what do they want exactly, because the questions under the task won't be direct on whether to find the mean, to find the mode or median. When you analyze this task, you are saying represent the data in a frequency distribution table, then determine the number of bags of maize above which half of the farmers harvested. Above which half of the farmers, once you say half, it takes us to the middle value. middle value. We want that value, the number of bags, which cuts halfway the distribution. So 50% is a half because it is 50 out of 100, which is still comes to this. So it means that this task is telling us to find the median. So let's represent our data in a frequency distribution table. But our representation, remember that you can never represent data without a title. We want to make our data to be meaningful. So the first thing we shall say is to have a title, a frequency distribution table. A frequency distribution table harvested. So in actual sense, if at all you have few number of bags that you harvest monthly or yearly as a farmer, you will never be given a lot of fertilizers. You'll be given many fertilizers depending on how much you produce at the end. So this is our title, and this time round, you realize that you have been given an interval. The interval that you have been given is 10 under the scenario. But when you look at the data, you must look for two things. You must look at the biggest and the smallest. We have 20. You locate, is there any other value that is smaller than 20? You locate throughout your data. So you realize that the smallest value is a 20. So it is always better to use the smallest value as it is given. Though we can accept someone who uses 15, just below that, to capture this 20 here. But the best way is start exactly with the least value from the data collected. Because this shows that the minimum person could, the farmer who could produce the least could produce 20 bags of maize. So we are going to have our frequency distribution table with the classes. But this class here, we shall have to use an interval of 10. So from 10, our classes will be 20 to 29, then 30 to 39, 40 to 49. So it's not a matter of just writing endlessly. You write depending on the data that has been given. Which one is the highest value? Which one is the least value? So as you see, there is some 87 there. So you can't stop on 79. So you'll also move from 80 to 80, 89. So you have captured this. Then you have also captured 89. So I think that is it. Now, the last thing is on this class is that some candidates always make a mistake. They write 20 to 30 and they think the interval between this is 10. No. This is wrong. When you look at between 20 and 30, we have 11 steps. So the best way of analyzing this is listing from, you have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So this is the first interval. The first step, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by the time you reach 10, you are on 29. So it means that the interval that has been given as 10, when you start from 20, you should stop at 29. The other way is use of the fingertips. You can count the fingers. By the time you reach the 10th finger, you'll be at. So when you start by saying 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. By the time we reach the 10th finger, we are on 29. So don't get confused. So let's progress. So now we have this. So we have to check the number of times that this range, this is now, we are grouping the data. But by grouping this data, we want to now simplify it. The simplification will help us to analyze and make meaning out of it. So in actual sense, we shall now start by saying, to form the tallies that will help us generate the frequencies. So we shall have frequency, then, so let's start off. 20 belongs here, then 40 belongs here, then 60 belongs here, 55 belongs here, then 36 belongs here, then 69 belongs here. These items are actually very simple. What you do, you can pause the video and then also try to do the tallies, carry out the tallies, and make sure that at least you have what I've got here. Mathematics is just by practice, and when you practice, you improve. So these items are easier to deal with so long as you try to practice each and every time that you have. So after carrying out the tallies, we have generated the frequency that these people from 20 to, in fact, those who had 20 bags up to 29, there were 4. These who had bags between 30 and 39 were 5. Like that. So you realize that the highest is 12. But now, since the task part A tells us to represent our information in the table, it is well presented. So part A of the item 4 has been done. But when we go to part B tells us to find the number of bags which are above which half of the farmers have. So when you say above which half of the farmers have, it takes us to median, as I already explained. So median depends on 2 things. It is a cumulative value that lies between the distribution. So it means that we shall get the cumulative frequency. So we shall now have cumulative frequency, and then we also have the class boundaries. So we said that to get the cumulative frequency, this first value is a 4 there. It is a 4 because the value before, we didn't have the number there. We always take it to be 0. So in actual sense, we shall have 0 plus 4 gives us a 4. 4 plus 5 gives us a 9. And 9 plus 8 gives us 17. So hope we are moving on together. Then 17 plus 12 gives us a 29. Then 29 plus 10 gives us a 39. 39 plus 6, that is 45. 45 plus 5, that is 50. So take note on this value. The last value under cumulative frequency should always be the sum of the frequency. So in actual sense, here we should have summation of f. But this summation of f, we normally just add these frequencies. Some people can represent this as just f, small f. So when you add these each value here, 4 plus 5, that is 9, plus 8, that is 17. This is plus 12, 29, plus 10, 39, plus 6, 45, plus 5, which is actually 50. So the value of summation of f should be the one that is the last under cumulative frequency. Then class boundaries are obtained from the class. So in actual sense, we look at the lower limit of the class and the upper limit of the class. To get the boundaries, we now subtract a 0.5 on the lower class limit. We shall have 19.5. Then we add a 0.5 on the upper class limit to obtain the upper class boundary. So this becomes 29.5. We do the same. By subtracting a 0.5 on 30, we get 29.5. And when we add a 0.5 on 39, we get 39.5. We do the same, 40 minus 0.5, 39.5, and then we shall have 49.5. We do the same and the process continues, 49.5 to 59.5. So that's what we have. We have fully represented the data on the table, and we are progressing in order to find the solution for part B. So as we proceed, we are looking at part B, where we want to find the number of bags of maize above which the farmers produce, half of the farmers actually. But now, the ogive can be the best way to analyze this. When you look at part C, you can now hit two birds with one stone, because part C also needs us to use an ogive. So when someone uses the method, it is okay for part B. But part C, the person will still need to draw an ogive to analyze this. So the best option would be the graphical approach, and it should have a heading or a title, an ogive to show the variation of number of farmers with the number of bags of maize produced. So we are going to have two axes, of which the first axis, we are going to have it here. So here we don't need to label it as the y-axis, since we are looking at an ogive, which is a cumulative frequency curve. And this cumulative frequency curve, we need to utilize the cumulative frequencies against the number of bags, which now we have bounded as the class boundaries. So we now start by saying that this is, along this axis, we have the frequency, or someone can represent it as the number of farmers. Number of farmers. Then we have our horizontal axis. This horizontal axis, we are going to have it here. So this is our starting point. So this horizontal axis, we have the upper class boundaries, or the upper number of bags bounded. So, but the best way is upper class boundaries. So these upper class boundaries, we are looking at these. Why are we using only upper class boundaries? It is because there is a repetition. Other than the class, which is not repeated at every stage. You have 39, you go to 40. You have 59, you go to 60. You have 79, you go to 80. But for the class boundaries, we have 39 and 39 repeated. The upper is repeated along the lower. So the best option would be we only utilize these upper boundaries, but we need to get a connection from the reference, because they are only, when you look at these are the only values which are repeated in the lower part. When you look at the lower part, all these values are repeated, except this value here. This value here, this one here, is not repeated anywhere. That's why we should begin with it. So we should begin with it as 19.5. 19.5 here. 19.5. Then we have 29.5 now, the upper. Then we have 39.5. Then we have 49.5. Then we have 59.5. Hope you're enjoying. Then 69.5. Then here 79.5. 79.5. Here we have 89.5. So we can stop there since we don't want to exceed the analysis which we have made. Then here we can use, the best way is to use a scale of 2 centimeters. When you have 2 centimeters, we use 5. Because on your graph paper, you realize that a better scale is when you have 2 centimeters on the graph representing 5 units along the y-axis. But here, as I have a shorter graph, I'm going to use 1 centimeter to represent 5 units. So it will be 5, 10, 15, 20, 25, then 30, 35, then here I have 40, then 45, and then here where we have this frequency, we shall have 50, then 55. But you realize that along this, our maximum value, it should always be encapsulated within the range which you have considered. So we are looking at cumulative frequency. So this is what we should have, cumulative frequency. We can first get rid of this. So cumulative frequency against upper class boundaries, therefore we have from 5. But some sample, you make a common mistake of putting the 5 here. It is still okay. But the best way is always to start from 0 as you go up. So we now need to start plotting. Plotting is that we are looking at the cumulative frequency against the upper class boundary. Even though we have begun with 19.5, of which 19.5 is the lower value here, yet these ones are upper values, we still undergo the restriction that we consider the 4, the first value, which is 4, with the upper value. So since we have 5 small boxes here, 5 small squares, so to reach 5, we need to, we have a 4 there. So the 4 will be 1 small square below 5. So it means that along 29, we shall have it there. Then the next thing is 9 and 39.5. So 39.5 is here, and 9 is 1 small square below 10. If at all you are using 1 centimeter represents 5 units. That's what you should be having. Then we continue with another one. We have 17 with 49.5. 17 with 49.5. So we have 49.5, then we go to 15. So from 15 we count 2 small squares. Each small square represents 1 unit. So it will be 17, 2 small squares after 15, and then we locate 49.5. So it will now, we shall put it there. Then now we go to 29 and 59.5. 29 is 1 small square below 30. So in actual sense, we locate where 59.5 is, and then we put a cross there. Then we now proceed to 39 with 69.5. 69.5 is here, then 39 is 1 small square below 40. So we shall locate it at this point, 69.5 there. Then we head on to 45 with 79.5. So realize that 45 is here, 79 is here, already on the axis. So you just locate that point of intersection of the two, which is that point as shown there. Then we proceed by going to 50 with 89.5. 50 is directly here. It is also there with 89.5. 89.5 is also there. We look for the point at which they intersect, and that is where we are. Now, when we have the lower boundary, which is 19.5, this lower boundary that you see, it was also once an upper boundary, but we got rid of that because its frequency is 0. We didn't have any number there. That's why we start from where we have these values. But this lower boundary, 19.5, was also an upper boundary. The way you see the 29.5 here is the lower boundary, but it is still an upper boundary in this first range. So it means that its frequency was 0. At this point, the frequency was 0 when we had the lower boundary. So in actual sense, whenever you're sketching this ogive, it is a curve or any other curve. You need to be small. You should use a smooth hand. Don't use a ruler to draw a curve. Use a free hand with a pencil. So join these points smoothly as you draw this cumulative frequency curve. Move like that, like that, like that, like that. And you don't exceed the point of the last point because you don't know that it is going up or down. So hope you can see how this is interesting, and this is how we can draw our own ogive. So after doing that, we now go back to what the task was telling us. The task was actually telling us to find the number of bags that are produced above which half of the farmers can produce. So in actual sense, we have to locate the median. So we need to label, this is part B. And in part B, we have not yet responded to the task, as we are saying that for this part B, we need to locate the median position. To locate this median position, we say that the median always lies half of the distribution, halfway. So that's why always we use n out of 2. But this is just a position. By having n out of 2, n, remember, n is the same as the summation of f. So in actual sense, we shall have 50 out of 2, and this will give us the 25th position. But that 25th position should be located on our graph. So we shall now come and then locate the 25th position under cumulative frequency. Then we draw a horizontal line to go and touch the curve. The point where it touches the curve, we draw a vertical line downwards because we want the number of bags of maize. So in actual sense, this 25th position is the one which is telling us that that value you are looking for, which is half of the distribution, is actually half of the number of farmers. So in actual sense, we are saying it is half of 50, which is 25. We locate it here, and then we get this value here. So this value is between 49.5 and 59.5. So it means that from 49.5, when you add 2.5, you'll get something of a 50. But make sure that you use a graph to get this answer accurately. So the median, for me, what I have the median as, from the graph, it is 56.5 bags. So we may not need to round off because we can have half a bag. So that's why I'm leaving it as 56.5, though someone can also get the median using the calculus part, the formula, and you'll also get an answer which is closer to that. So as we said, we always need to conclude. So the number of of bags of maize above which half of the farmers need to produce is 56.5 bags. Now, part B is done. So we can go to part C. Part C, in the scenario, they talked of retraining. And if at all we talk about retraining, it means that there is something which you are not satisfying. So they are saying that those farmers that do not produce bags that are 44.5 bags, if at all we have some farmers which are who are producing below this number, we should take them for retraining so that we can give them fertilizers to improve on the number of of bags produced. So here we also need to use an ogive. So we locate the number of bags. This is 44.5, and therefore you cannot locate 44.5, which is the number of bags. Remember, this cumulative frequency tells us the number of bags produced. Are you getting it? The number of bags produced, so we shall have 44.5 bags. Then we come here and locate for 44.5 bags. We shall come here 39.5, 49.5. So we need 44.5. So it is just between 39.5 and 49.5. So you locate where 44.5 is. So you draw a vertical line to touch the curve, and then you draw a horizontal line to touch up to where it meets the vertical axis. At this point, we get a value which is between 10 and 15. And when you count the boxes that are here, the small squares, there are 3 small squares, so which gives us 13 farmers. So in actual sense, we have 13 farmers for part C. 13 farmers need to go for retraining. Thank you for watching as we have gone through from item 1 up to item 4. You can subscribe, comment, and share for more. But for more information, you need to approach us on the KTD app, which has a lot of work, which has a lot of exercises, tutorials, guiding notes, games, puzzles, and mind games. So catch us on this channel next week, and still download the app on Play Store for more material.